All right, I think we can get started on time. Since I hadn't, here we go dark again, so I can't see you out there. How many people have been to the SQL sessions from yesterday or today? So most everybody. So I'm not going to introduce myself other than saying I'm Tony, I'm with SQL Server Engineering Organization. So we're going to talk about SQL Server vNext and support for Linux. So again, show of hands, how many people use Linux servers? A few people. Use other databases on Linux, MySQL, Postgres. All right, excellent. So I'm assuming there is interest in SQL Server on Linux, which is a good thing. So one of the things that we come to realize is that there are enterprises are diversifying their assets. A lot of people are starting to heavily depend on Linux. It's been going on for a long time, and we were starting to get locked out of certain places because SQL doesn't run on Linux, and people are starting to standardize on Linux. So we thought it would be a good idea to put SQL Server on Linux, so customer has a choice. You want to run SQL wherever, that's fine with us. That's what started it. And to be honest with you, it's not the first time we had this idea. Over the years, this idea was brought up many times in my career at Microsoft, but the conditions were never right for us to put SQL Server on Linux. This time around, we made a proposal, and Satya Nadella said, "Yeah, okay, go for it." So that's how it started. So we announced it last March that we were going to do this. We had about 25,000 people sign up to the private preview within the first 3 days of the announcement. Half of the Fortune 500 customers that we have were part of the list of 20-some thousand people who signed up to try the private preview. We had a limited private preview, sort of under a non-disclosure agreement. And then in November, we announced a public preview, and we started the regular SQL Server release process. And the SQL Server release process is, we start with the community technical preview, the CTPs, and there's a CTP1, CTP2, and then we start building release candidates, release RC1, RC2, and then we have the final build, and it goes through a bunch of processes, and eventually it GAs and is available for everyone to use. So right now, at this moment, we're in the CTP1 cycle. We've done 3 releases so far. So the first one came out November 15, CTP 1.0, and then CTP 1.1 came out in December 15-ish, and then CTP 1.2 just came out, I think, yesterday, or it's going to be tomorrow. We have a monthly cadence. And we're not talking about SQL Server on Linux. We're just talking about SQL Server in general. So we're not doing like here's a SQL Server thing on Linux, which is different than SQL Server on Windows. It's just one SQL Server. So when we have a CTP, we release the Windows as well as the Linux, and that's the plan. So we're not going to have a SQL Server for Linux. We're just going to have SQL Server, and it's just going to be on Linux or Windows or Docker images. The form you choose to deploy is whatever that is. So a lot of people think that we're going to do like SQL Server 2016, the Linux version. That's not the case. We're just doing the next version of SQL Server will support both platforms. And that's how we're going forward. Our goal is to have this done sometime in 2017. So there will be a new version of SQL Server that will come out in 2017. Now we have a substantial portion of our engineering organization working on putting SQL Server on Linux, but by no means the entire Microsoft SQL organization is doing this. People are still working on various areas of SQL. The optimizer team is working on optimizer improvements. The storage team is working on column store and in-memory improvements. So there are other features that will come as part of next version of SQL Server. But the number of new features that are going to come out is going to be fewer than before, because now we're almost doing a release a year, right? 16 came out, and then in 2016, and the next version will come out in 2017. That's a much shorter cycle than, let's say, when we did 2008 to 2012, or even 2014 to 2016, because that was almost a 3-year period between, when the developers started working on 16, right? And by the time it shipped, the delta from 14 was about 3 years. So that's what we're doing. And when we look at what customers are doing, what we see is customers are enterprises and others, large enterprises and small. There's more and more running stuff on Linux and Windows. Some are mixed, some are exclusive on one platform or the other. What we see is large enterprises are starting to adopt private cloud, and a lot of private cloud stacks run on Linux. So that was another reason. If you're an enterprise, and you're a very large enterprise, and you decide that your application platform for all the apps you're going to write and deploy is going to be based on Pivotal, Cloud Foundry, or OpenShift, those are all Linux-based, and so we want to make sure that SQL is part of that. And we also see that the number of languages people use to build apps is just exploding. So a lot of people are using Node.js, JavaScript. People are still using PHP for building websites, and a lot of these things, there's a huge body of stuff out there for some of these languages in the various platforms. So we're going to try to support all of those. So this slide should look familiar to you because the theme shows up in our thinking in all of our sessions today and yesterday. Basically, choice is king. And as an organization inside Microsoft, SQL Server is rather large. If you took SQL Server and split it out of Microsoft, it'll be in the top 10 largest software companies on the planet by revenue. So we're large. And so we have been given the order to go and make SQL available for everyone, everywhere, and give customers the choice. And so we're not bound by any rules that, because it's a Microsoft product, it'll only work with Microsoft languages. That's not the case anymore. It really never was, but the perception was always there. Like most developers write code, they think, SQL Server is for the .NET apps, and then I'll use Oracle if I want to write Java apps. But SQL Server has a JDBC driver, and you can write Java apps for SQL Server just as well, right? All right. I'll just say a few things about open source and Linux, just to put that out and clear things up. We're not open sourcing SQL Server. Just so we're all very clear about that. Just because we're putting SQL Server on Linux doesn't mean we're going to open source it. We have other products on Linux. Of course, we have HD Insight on Linux as part of Azure. We also sell the Microsoft R server on Linux. This is both open source and not, so we have a version of the R server which is capable of handling lots of data, huge memory sizes, and parallelism. You can buy Microsoft R server and install it on a Linux machine to go and work with the Teradata database. So no Microsoft things there. There's a lot of Linux in Azure, like 30–40% of cores in Azure are running Linux. And we've recently introduced this thing called Visual Studio Code as part of our developer organization. This is a kind of lightweight editor, and it's a great debugger, so developers can install code on Linux or Mac or Windows, and you can write code in just about every language you can think about. It has the capabilities to allow you to do intelligent IntelliSense and debugging, and so it's a really nice tool. We support that for SQL, so if you get Visual Studio Code, install it on your Linux machine, install a SQL Server extension for it, Then you can connect from that Linux machine with this nice little GUI tool to SQL Server and run queries and edit, right? What we are doing, most of the tools that we are now working on are open source. So the extension for Visual Studio Code and Visual Code itself is an open source project. You can go look at it, you can go contribute it, you can take it, change it, and we're going to continue to release most of our tooling as an open source. We've also moved to releasing our drivers and open sourcing some of it. So we just open source our JDBC driver. You can go to GitHub and get the latest SQL Server JDBC driver. It supports the latest JDK, supports SQL Server 2016, all of the features, including always encrypted and so on. And one of the reasons we did this is because there's so many languages that pop up out there, like Rust comes out, and people want to write code in Rust and connect to SQL Server, and so somebody goes out and implements a driver for SQL Server in Rust. But they're all doing it from spec. So we decided if you open source one of our full stack drivers, it would provide a reference for everyone who wants to go write a driver for SQL Server. So our JDBC driver is all JDBC from the network layer all the way up. It's all written in Java. And you can use it as a reference for writing code. If you want to write code in, go build a SQL Server driver in Go, you could use our code as an example. We're also contributing to the various open source drivers. We found that some of them are better than what we had, so now we've shifted our investments towards that. So we'll talk about some of that. So that's kind of the lay of the land. The number of downloads of the SQL Server on Linux over the last, it hasn't been 2 months. I guess January, this week it'll be 2 months since we publicly released that thing. And 2 weeks ago when I looked, it was more than 100,000 downloads of SQL Server on Linux. So there are a lot of people who are running SQL Server on Linux. We actually have a couple of people who've gone into production against our recommendations. So just as a recap, SQL Server 2006 came out in June of 2016. SP1 came out in November of 2016, and we hope that the next version will come out sometime in 2017. And then you can imagine what we're going to call it. And people have been asking about the licensing. It's like, oh, well, what is the price of SQL Server on Linux? There is no pricing on SQL Server on Linux. It's not different because you buy SQL Server licenses. You can run it wherever you want. So if you have license for 4 cores of SQL, you could put it on a Windows machine. You can put it on a Linux machine. We really don't care. So the SKU model and the pricing will be exactly the same. So there's no difference there. And we will have all of the SKUs, Express, Enterprise, and so on. So we're also, with in the old days when we released SQL Server, you could go buy a license for the version that you had and just use it for the next forever, right? Because you paid for licenses for your 2005 and you use it for the next 20 years if you want. It'd go out of support, but you could continue to use it if you want. With the more frequent releases, I think we're encouraging people to really think about software assurance to see if that makes sense for them, because you can get all of the updates as they come out and you can choose to adopt or not. But this is the model. We also changed our support model for SQL recently. It used to be that you have 5+5 support, so when you buy SQL Server, you get the 5-year full, and then the plus 5 years when you have the software. So now we've added the 6-year add-on, so you can use SQL Server that is supported for 16 years. The last 6 years is basically the critical fixes and security stuff, right? Because we have some customers that buy a version and want to use it for 15 years because they deployed it in some kind of a manufacturing equipment that has a life of 15 years or something. So That's the rules all follow the same. There's some other interesting things about SQL Server on Linux. You could pick up SQL Server and install it on an Ubuntu machine and run it. The SQL Server will be supported by Microsoft, but your Linux is a free distro and there's no support for it. So Microsoft will do a best effort to support you on the free platform, but our resources are limited what we can do for you there. You choose to run SQL Server on a Red Hat Enterprise Linux with support from Red Hat, you will have a different support experience because Microsoft and Red Hat collectively will support you and will make it very easy and seamless. We're not going to go and try to prevent you from running SQL Server on a free unsupported Linux. We're going to try to support as many distros as we can, but we're not going to have the same support capabilities because basically we have no partner on the other side to deal with system and OS and issues like that. So that's how we're going to start. We're not going to limit, but we'll be limited in what we can do for you if you run into trouble. Okay. So people, first question usually they ask is, I put SQL Server on Linux and everything is there? And the answer is mostly. There are some things that just are not going to be there in a SQL Server on Linux. Some of the stuff that may not make sense. For example, there's a concept of a file table in SQL Server where you can have transactional capabilities across SQL Server making changes to the data, and a Windows application through NTFS can make transactional changes to the data. Right? So it's an integration with Windows. So the file table feature, which I don't know, probably nobody here uses. You use file table, right? So I don't know how you would use file table on a Linux machine that doesn't have the concept on the other side, right? That would be we're not going to bring Windows to Linux, right? We just can't. So there are some parts where it is so tightly integrated with the operating system that is going to be difficult to enable on a different operating system. Now that doesn't mean a feature like file table doesn't have a valid scenario. We might have to figure out other ways of supporting scenarios, the use cases for that, but it certainly is not going to be the file table thing which has Windows dependencies. There are a few other things like that. When you do XP command shell and you drop in a DOS command window to run a DOS command, we don't exactly know what that would do for you on Linux, right? XP command shell, there is no DOS command there. So we might replace that. Say, okay, you do an XP command and you drop into a bash window, right? Maybe then you'll write bash scripts instead of, Windows command scripts. But that's the stuff that's going to take some time because that's where we really need feedback. So we're really trying to encourage people to speak up with your scenarios. It's like, I want to take this app and put it on a Linux machine, move my Windows SQL thing to a Linux, but I need X, Y, Z to make sure that it works. So that we know exactly what people are going to do so that we can enable it. Now, I'm not sure anyone has any expectation that DOS commands are going to work on Linux, but what are the alternatives and how do you do those things in a Linux world? Linux databases that are native on Linux may or may not have any of these features. But that doesn't matter because the SQL customers are accustomed to those features. So they're still a SQL customer even if they're on Linux. So we're going to have to figure out ways to satisfy those scenarios. So right off the bat will come up and this is what it looks like. And just because a feature isn't there on any given day doesn't mean that it's not going to be there forever. Even after we ship, we're going to continue on to add some of the scenarios that we may not be able to get it in on the first iteration. So again, we would ask all of our partner customers to be vocal about their needs so that we can deal with that stuff. As far as tooling is concerned, We will have new tooling, which is cross-platform, kind of like VS Code with the SQL extension. But we will also continue to support and invest on the Windows tooling. And there's nothing that limits you from using the Windows tooling on any SQL server, regardless of where the SQL server is running. So I use SSMS on my Windows machine. I connect to a SQL server that happens to be running on Linux. SSMS doesn't care, it works. And there are some scenarios that have dependencies on OS, and we fix those. And so there is a new version of SSMS, 17 point something, which runs in parallel with 16 point whatever that's out there, that also supports the Linux editions. So
you can have SSRS, like have the SQL server running on Linux and then connect.
Absolutely. So you can buy, I don't know, 10 licenses for SQL and have 4 of them running SSRS and SSAS on a Windows machine, have 6 of them running on a Linux machine for SQL Engine, right? You do that today. You have X number of licenses that you buy, and you may run them on different machines for different purposes. We're assuming people will continue to do that. I don't think people are going to go and revamp everything, right? But just so you know, and just so everybody's clear, this is not about moving SQL Server customers from Windows to Linux. What we are seeing is a lot of demand to run SQL Server on Linux in new scenarios. And you can imagine the various conditions. Like there are some databases, traditional databases that have been around that are not so popular anymore, and people want to move away from them. But they are not willing to change platforms. So we have some customers that run Sybase on Linux. They don't want to use Sybase anymore because of the acquisition or the complications, or for whatever reason they don't want to be an SAP customer, so they're trying to move away from Sybase. But they're not willing to move away from their infrastructure, so they want SQL Server on Linux so they can move their Sybase stuff to SQL. There's lots of scenarios like that. So we're trying to accommodate all. But we definitely have some customers who have SQL running on Windows and they want to move to Linux as well. So we have seen it in the variety. So what works? So there's a list of stuff that works, various features and such. One of the coolest thing is you can have a database running on Windows. You do a backup of that database. You copy the files to your Linux machine, fire up SQL, restore those databases, and off you go. So the SQL Server on Windows, the SQL Server on Linux, they use the same file. They're binary compatible with the database. Again, I want to stress that SQL Server on Linux isn't some other kind of a weird port of SQL Server or a broken port. It is the same SQL Server. So it's a cool demo. What's even more interesting is you might have some CLR functions in your database running on Windows, and you restore those. They continue to run on Linux. So we've managed to get CLR working in Linux, even 4.6 or whatever you may have, right? There is .NET Core, which is open source .NET, available on Linux, but we support the thing which is in SQL Server on Windows. Yeah.
Is always not available on Linux?
It will be very shortly. In fact, I have some slides on Always On, which we will get to. We got the DMVs to work, so you get all the DMVs and stuff. We have some really cool, interesting stuff with the DMVs. If you're a Linux user, you can cd to /proc and do an ls and see the processes running. We've mapped the DMVs to Linux file system, so you can cd to SQL DMV and ls and see the stuff, and you can actually grep and look at the DMV output. So it's kind of nice. You don't actually have to go inside SQL to get DMV data. You can just do it from Linux shell. We've also done the other way around, which is we've mapped some of the critical Linux kernel objects inside SQL. So you can go do a select from the process table of the Linux machine you're running on from SSMS. So we've done some nifty little integration to make life easier for people who are accustomed to one way or the other. Like if you're a real Unix, Linux person, right, you can go look at the SQL Server statistics without actually running SSMS or select. And if you're a real SQL person, you can go look at Linux stuff from SQL. Replication agent, encryption, all of the encryption stuff works. We are supporting right now Red Hat, SUSE, and Ubuntu. The packages and such work in other places. Like obviously, if you have Red Hat, CentOS works. We have a reasonably good size matrix that we test, but these are the primary ones that we work with. And then we are putting a lot of efforts behind Docker. Docker is the most popular version of SQL on Linux that's being downloaded. Plus, all the Mac users use the Docker image to get their hands on SQL Server on a Mac. When we initially announced that we were going to go do SQL Server on Linux, the social media kind of blew up, and there's a lot of conversation about it. And the Linux diehards had a bet that Microsoft will royally screw the installation experience of SQL Server on Linux. It'll probably be some ugly, tarball that you have to unzip, and right. So we got that bet right away, and so we made sure that the installation experience for SQL on Linux is really nice and native. So if you're on Red Hat, it is Yum. If you're on Ubuntu, it's apt-get app. It's just apt-get install SQL Server, and boom. That's how it works. Yum install MS SQL-server. Microsoft has a repo now, a Linux repo. We use it for lots of other things. So the Microsoft stuff comes from the repo. You register the repo with your package manager, and off you go. You can have SQL Server installed on your machine in 5 minutes, maybe less, depending on your network. Okay, security is something that people really wonder about because, of course, when you use SQL Server, there's AD and all of that stuff happens to be Windows. Well, as it turns out, people use AD in all kinds of conditions. Lots of people who run Linux stuff but are still using AD because it's a reasonably good identity management system, and so it works. So a lot of people, even who run stuff on Linux, use AD. So we have we're going to make all of that stuff work. So you're not just limited to like SQL login and a password. There'll be AD integration. Kerberos stuff will all work. And this is how we look at security. There is the protecting of the data, like stuff on disk. And then encryption for data in transit, SSL, and so on. And then there's the issue of the access control. Like, how do you gain access? How do you authenticate? Like login, password, AD integration, Azure AD integration. And once you established your identity, and then it's the authorization, what do you have access to? What are you authorized to touch? So when I log into SQL with my identity as Tony and somebody granted me access to do a select on a table, right, that granting of the access is the authorization, and the authentication is the fact that the database has identified me as Tony and has verified that. So anything related to the authorization is exactly the same. There's no changes there because there's no changes there. Anything related to authentication using the SQL Server login and password is exactly the same. And we intend to make sure that the authentication through AD will continue to work, and then other systems that have some kind of an authentication system with Kerberos will also work. So those are the plans. And you can see we've gotten the SSL, the TLS, we've got all the encryption stuff working on Linux. So I think that at the end of the day, you should not notice a difference with most of the stuff, except the operational configuration of how do you get the Linux machine to connect to whatever authentication system, whether it's AD or some bridge to AD. You know, that's the usual stuff that people do in the Linux land. So, always on. Always on is our HADR story, and it'll continue to be our HADR story. We will provide all of the functionality. So we've done some clever things here that we think that our Windows customers will also appreciate, not just a Linux thing. So obviously, you know, if you have a SQL Server running in a VM, like an Amazon or Azure or somewhere else, where some fabric is ensuring that your VM is always up, and that's your availability mechanism, well, obviously that'll work. The VM dies, you know, you're running in Amazon, AWS will spin up another VM. What we do in that condition, make sure that SQL can recover very fast and not lose data, and the backup and all that stuff works. So your basic HADR story backups work. You know, we work in a VM environment, minimum downtime, come back as fast as we can. Then our standard HADR stuff is, you know, you have a failover cluster, you can have replicas, you can do replication with, you know, always on. You can have basic availability groups, which was introduced in SQL Server 2016. So with SQL Server Standard Edition, you can use always on with availability groups with 2 nodes, where the secondary is not readable. And with Enterprise Edition, you can have multiple replicas, and it can be read and whatever. So that stuff works. And then for the mission critical stuff, you know, the availability group and all of the stuff that you're used to. Now the first question we get is, okay, so on Windows, I need to set up Windows clustering, you know, for failover clustering or even AG. And Windows clustering is a Windows thing, it's not a SQL thing. So a lot of DBAs and system administrator, you know, are very accustomed to setting up a Windows cluster, and then you install SQL with always on. Well, on Linux, there is no Windows clustering. So what do you do there? Well, it's true there's no Windows clustering, but there's a whole lot of clustering software out there for Linux. In SQL Server, always on has been very tightly integrated with Windows clustering. Now, some people think that it was a bad idea, that that integration should have been done at a more layered sort of a way, right, to keep the management a little more separated. And some people think that integration was really good because it made things simple. Well, the fact is that that kind of integration will never work in the Linux environment. So we've disintegrated the clustering fabric from always on. So you can have always on availability group replication now with a pluggable clustering fabric. And on Linux, we have examples, we have the code, everything working with Pacemaker. So, and Pacemaker is fairly popular Linux clustering software, and always on availability group will work with Pacemaker. If you don't like Pacemaker, you want to use Service Guard from HP because you love HP and you use their product, then that will be integrated as well. So you can plug in availability with SQL Server, always on, with Service Guard running on an HP machine. So depending on the OS provider and their, right, you can run Pacemaker on an HP machine, you don't have to use Service Guard. And so we're looking into a number of these things, and we might expand the list. So right now, Pacemaker works, Service Guard will work. There are other things like Oracle Clusterware. If you're running Oracle Linux, we're looking into that. But the reason I said that some of the Windows customers may like it is because we'll have a cluster-less always on, so you can have replication without clustering. You won't get automatic failovers because you don't have a clustering fabric, but let's say you want to do an always-on group to replicate something and do manual failover because you're upgrading some hardware or upgrading some machine. You're doing this as a way of moving a database from one place to another. You can set up a cluster-free, always-on, replicate, and then pull the lever, do a manual failover, and off you go. So you'll get some more flexibility on managing always-on even on Windows. Does that answer your question? Any other questions around this stuff? All right. So tooling. I kind of covered this, but of course the Windows tools will work. So SQL Server tools, SSMS, SSDT, DACFX, and all of that will work. Third-party tools will work. If you're using a backup product from a third-party backup provider that integrates with SQL Server, that will continue to work because we're providing those APIs to the people who build backup tools. So the VDI stuff will continue to work. So we have a VDI implementation on Linux, and that stuff will work. Visual Studio Code extension, cross-platform, works everywhere. And then we're working on new cross-platform DB admin. And so we're pretty open about this. We're thinking about it. We're going to work on it. I don't know when it'll be finished. It's not a big giant secret, and it'll be open source. So it will not replace SSMS. We will continue to support SSMS because SSMS is very tightly, coupled with Windows, and that will continue to work. But we'll have constellation of tools as opposed to one giant tool that does everything. We'll have that as well, but so that's our plan going forward. If you haven't tried VS Code, it's really nifty. Like I use VS Code now on my machine when I want to edit files. So I don't use Notepad anymore. Even if I just want to have a little text file, I pop into VS Code. You can do any kind of a language in it. So the SQL extension is nice, and you can go change it if you want to play with it. You can start contributing to it. All right, so I'm going to talk a little bit about how actually we did this, and it's a bit controversial, but I think it's a really great way of going about this. So SQL Server is a very large product. I mean, we're talking 30, 40 million lines of code when you look at the entirety of SQL Server with RS, AS, IS, SQL. So we didn't port it. Like we didn't take the code and port it because that would basically make sure that you're going to have compatibility issues forever. So what we did is we have this platform abstraction layer which we use to abstract out what happens below and above the stack. We've always had the SQL OS. I don't know how many people know about SOS, SQL OS. SQL OS is the thing that manages the threads, the memory, the I/O for SQL Server. It's part of the SQL Server engine. But it is a very distinct piece of the SQL Server engine code, and it's very much something that interacts with all of the OS-related things. So we've extended that SQL OS into the PAL, and the SQL PAL is now an abstraction layer, and then you run the stuff on top. Now, one of the interesting things is SQL Server on Windows and SQL Server on Linux are supported on our x86 machines. So you can't take the SQL Server on Linux and run it on a Power architecture or some other architecture which is not x86 because we have not done away with our dependencies on Intel instruction set or AMD, right? So SQL Server on Windows and SQL Server on Linux work on x86, x64 architecture. At the end of the day, an Intel instruction is an Intel instruction. It really doesn't matter. When you do a 2+2 in assembly language for Intel, you can't really tell if that assembly language is a Linux thing or a Windows thing. It's just a set of instructions. The only thing that matters is that how do you load this thing and start executing, and the binary format of an executable on Linux is different than the binary format of an executable on Linux, and how the operating system loads that piece of code. But once the code is loaded for execution, the instructions are the same. So we have some clever tricks that we can take the DLLs from SQL Server that implement XML parsing and take that DLL, which is built on Windows, and run it on Linux, which eliminates the need to have two versions of the code, right? Because most of the XML parsing in SQL comes from a bunch of Windows libraries anyway. So this is how we get the same exact stuff running on SQL on Windows and SQL on Linux. And the host extension and parts of the PAL are natively compiled for the operating system. So I/O and memory, all of that sensitive pieces of code that have a lot to do with performance are native. And that's kind of what the picture looks like. If you're interested, we've extensively blogged about this. If you go out there and you look for SQL Server, PAL, Slava, you'll find all of the articles that have been written about this. There's a couple of magazines that have written articles describing how the whole thing works. And there's a piece of technology that we use from Microsoft Research to do this mapping to get the executables rejiggered from Windows to Linux and have them execute. It's called Drawbridge. Drawbridge was a piece of technology that was developed by Microsoft Research. And so we leveraged that to get SQL Server run. Now, people say, oh, so you're emulating? And the answer is no. We're not emulating x64 instructions on an x64 machine. We're just executing them. It's just how do you load them is a little bit of a trickery that is going on there. Now, one of the nice things about this is we don't have to constantly port between platforms. And when developers implement a new feature in SQL, most of the code is way up in the SQL Server engine. It's completely unaware of whatever operating system that might be running underneath because it just relies on the SOS. And that's all the code needs. So when a developer writes a new feature for SQL Server, it's instantly available on Windows and Linux. And there's no porting. And when we release SQL Server, we release Windows and Linux at the same time. It's not like, oh, here's the Windows version, and then the Linux version will be ported 6 months from now. And trust me, this is a really good way of going about it. I worked at IBM, and I worked at Informix. I've worked on Oracle porting to different platforms. And then, when you end up doing these ports, like, some things are available sooner and later, and some things work and some things don't work. And there's so much effort that goes on here. In this model, it's very nice and clean. So, any questions? Yes?
So the SQL call layer only starting using license. The current version is everything's
Yeah. So SQL, so this is all in the next version. By the way, we don't plan to use like the PAL for Linux but not Windows. All of it will run in this model. But we're making the Linux thing work first, and then we'll do the Windows switch as well. But everything will run on this model, starting in next version of SQL Server and forward. SQL 2016 does not run on Linux. So, yes?
So I think the concept is very similar to the virtual machine, right? I mean, this is a high-level concept. I will try to say some performance.
So we basically made a promise that SQL Server on Linux will run and with the same performance as SQL Server on Windows when we started to our executives. And that is a success criteria for us. And we were confident that we can actually do it. And we have done a lot of testing now, and we're pretty comfortable about the fact that SQL Server on Linux will have very similar performance characteristics as SQL Server on Windows. Now, in our tests, there are some cases where SQL Server on Linux runs a little faster. In some cases, the SQL Server on Windows runs a little faster. On average, it's the same. So we had some really shocked customers who were posting that they ran some tests, and SQL on Linux was 10% faster than the same exact thing on Windows. And they wanted us to explain it. Like, well, we said it'll be about the same. That's about the same as far as we're concerned. So our goal is to ensure that that continues. Now, there are some edge cases. Like if Linux doesn't run well on a 640 core, 24 terabytes machine, there's only so much we can do, right? So I don't expect that we, as C-equal, can ensure that Linux and Windows are always equal. We can't. This is why sometimes Linux could be faster and sometimes Windows can be faster. But it's not going to be because we did something to make something slower or faster. And it's really, the concept is kind of a virtualization, but it really isn't a virtualization because we're not adding a layer. Like, we're not adding layers into everything executes directly in the same process space. So we're not making a call from one place to another. Anyway, I encourage you to go read the blog post about SQL on Linux, which explains the stuff in detail. Oh, you want to see it? Let's see. So I have a machine here. It's a Ubuntu machine. I happen to be running the, I actually have the Linux subsystem for Windows, so I can get a bash shell, so I can SSH from my Windows machine directly to my Linux machine. So this is what it is. So this is my bash shell, right? So let's see. I can start a new bash shell. So that's my Windows machine, my Tony Pet Surface Book 2. I can do SSH to my Ubuntu machine. And here it is. That's just getting a shell, right? Okay. Let's get it there. So there's no SQL running on this machine. However, I had previously installed SQL Server on this machine, and I've deleted it. I created some database. And when you install SQL Server and then you uninstall and get rid of it, it doesn't delete your databases, just like Windows. You know, you set up SQL Server and delete SQL Server, it doesn't go delete your databases. So next time I install SQL Server on this Linux box, it'll go find my database. Says, I have a database here. So let's install it. See, that's how I removed it. That's not exactly what I want. Let's just sudo apt-get install ms SQL server. All right, so it's going to the Microsoft repo to download the SQL package. And as you can see, it's 148 megabyte package. And then it'll install it. Now, we have some customers say, hey, how come I can't get 148 megabyte package on Windows? Well, we've taken some beating from our Windows customers. So it's going to unpack it. And as you can see, like, apt-get install is just a, it's an Ubuntu thing, right? Debian package. So I think we did win the bet about us not screwing up the install experience. So I think that's it. And here, I'll show you some instructions as well. Like, this is handy. So this is the Microsoft repo. So you curl the config and drop it into your package manager directory. And you do update, install, and you go through the process. And then this is the SQL Server setup. So I'm going to copy that and run that. SA password. Do you wish to start SQL Server now? Yes. Do you want to start it at boot? Yes. Okay, setup completed, successfully started. Okay, so SQL Server is running on this box. Here, let's go connect to it. It's on my local machine. Oops. All right. So Microsoft SQL Server, CTP 1.2. Oh, that's interesting. So remember I said CTP 1.2 is going to ship sometime yesterday or tomorrow? It shipped in between the time I ran this test in the speaker room and now. That's why it had to go and download it again. Because usually if the package has been on there, it's in the cache, you don't have to download it, but it's the new version. So there we are. We have upgraded, I guess. So previous version that was installed was CTP 1.1. And as you can see, it's on Ubuntu, and the version is 14, right? Now, you know that SQL Server versions are a little wacky, so 13 is 16, 14 is the next one, right? 12 was 14, and 11 was 12, right? Don't ask. So, SQL Server, so I have this your TempDB model, MSDB. I have this TPCH line item table. Some data in there. Originally, I think I restored this database from some old Windows machine I had. So that's your SQL Server. By the way, this is the actual Ubuntu VM also running on this machine, which hosts the Linux running there. I have a Red Hat version as well. And here's my SSMS running on this machine, connected to, well, let's disconnect and reconnect since that was, oops. And there's that TPCH database. Right. So, nothing to it, right? It just works. C drive. There's no C drive on Linux. Huh? What was it? Yeah, we can go look. So on this Linux machine, there's the file systems, right? And I can go to /opt. There's Microsoft, MS SQL, bin, right? Lib. That's where the stuff is. There's MS-Conf, yeah. Well. Anyway, I don't have permission. There's the database files. And all that stuff. So SQL Server knows how to do the backslash and C:\colon and a slash, so it's native on Linux. So you would have to use slash and directory structure. When you restore a database that was backed up on a Windows machine from C:\colon, backslash, whatever, you do the restore with move to the new location so that the restore process will remap C:\colon backslash data to slash my stuff slash data. Make sense? So, any other questions? Yes?
Tony, one of your slides you showed to be determined for the maximum database size.
Yes.
Is that something that we will get our eyes on pretty soon, or what's the reason for that?
Well, I think we have to push some of the limits on Linux, the file system limits, the core limits, the memory limits. We're very comfortable with the stuff on the Windows with because we do the Superdome testing, we have this joint thing with HP. Every time they have a giant machine, there's a joint testing that happens. So we know SQL Server can run like TPCE benchmarks on a Superdome and a TPCH benchmarks and, with the bajillion terabytes of memory. We have to do that work for Linux, and so we're doing that with our partners. So as you can imagine, all of the hardware companies are really excited about this because it gives them a little bit of a leverage over other database companies, right? Because they have some exclusive situations going on there, right? So we will do that, and I don't expect to be anything small. Like we're talking about, will we support, more than 600 cores, or will we support 24 terabytes? We have to actually test it, right? The stuff we're talking about, machines with a couple of terabytes of memory, and we're not concerned about that, right? It's just at the high end, you have to kind of figure out where the limits are.
So basic administration stuff, that's like same as for Windows?
The SQL stuff, yes. Yep.
Is the SQL agent running as a separate thing?
Yeah, we're working on a SQL agent. Obviously, SQL agent has similar issues because agent has command shell, right? So we have to figure out how to map those things to bash, right? So if you move from Windows to Linux and you have extensive scripting in command shell and you use that from agent, right? You might have to do some work because the Windows stuff is not going to be there. All right. Other new features. I did say that it's not just about Linux, right? So the next version of SQL. So one of the things we did is the optimized query processing with machine learning. What does that mean? Well, Optimizer's job is to predict what would be the best plan, right? That's all it does. It tries to guess what is the best execution plan for any given query. Sometimes it's right, you get a good performance. Sometimes it's wrong. So now we've added this learning mode so the optimizer can do some machine learning and get better as time goes by with a given workload, right? So when it sees stuff that it has seen before and it had predictions that may or may not have gone so well, it can now adjust for those. And one of the things we're also doing is this dynamic memory grant thing. So the optimizer will estimate how much memory you're going to need for a given query, and it wants to make sure that you're not going to run out of memory in the middle of the thing. So it allocates a bunch of memory. Sometimes you don't need that much memory, but it's generally conservative. So you end up with a query that gets this much memory, but some of the memory just goes to waste. But the memory is allocated, so some other query that needs memory may not be able to run because it has to wait for the memory grant before it can get the memory, before it can go. So our goal is to pack this thing very accurately and efficiently so things can run and so we can fill on the spaces. And that's the whole thing about the dynamic memory grant stuff that we're introducing in the next version of SQL. so that our memory predictions for your queries are more accurate so that you get better throughput. You get better parallelism because you can run more query threads because nobody's waiting for memory grants because memory is being used more efficiently, and right? And so we're trying to reduce the waste of memory. Yeah, I say, this is like super duper optimizations that people don't care about. But with containers, virtualization, clouds, people paying 17 cents a minute for the stuff they're using, and if they could only pay 12 cents a minute, it'll be cheaper. So a lot of people are interested in being more efficient. I mean, that's the whole thing about the cloud, right? The efficiency, the margin is in the efficiency. So this is one of the things that's going to be in there. And the reason I use this particular thing, because this is a good example of, again, our thinking in engineering about the direction we're taking. Learn from the learning, do better. Here's a list of stuff, lots of stuff. It's all published, it's all blogged. You can go find out. Every one of the monthly releases that come out have a whole list of everything which is in that release. So if you look for SQL Server, vNext, CTP 1.0, release, blog, right, Google it, you'll get to this stuff. But this is the stuff that we did. So the compat level for the next version of SQL will be 140. So all of the optimizer improvements that are going in are going on their compat level 140. If you install the next version of SQL Server and you set the compat level to 130, you get the SQL 16 behavior. If you set it to 120, you get the SQL 14 behavior. So if you don't trust us to do the right thing, just set the compat level to the thing it works, and then figure it out over time, right? We've made a lot of improvements in the in-memory stuff, better compatibility with the T-SQL construct, continuously improving column store. We've added some new collations for our friends in Japan, and then improved some of the string functions, because a lot of time people write C# or .NET code to do string manipulation because T-SQL doesn't do a good job. So we're trying to improve our string manipulation stuff so that you don't have to go write C# code to do string manipulation. We're going to introduce the online NCCI build, a lot more batch mode work, and then temporal table. We're adding retention policies for temporal tables, which were introduced in SQL 16. And then we're improving R. We're doing some improvement in the scoring so that you can do a single row, single transaction scoring with very little overhead, as opposed to batch scoring, right? So we call it the real-time scoring. So there are some of the smattering of improvements going on into SQL 17. And as I said, most of the team that's working on SQL Server, they're just going in their merry way, implementing features and improvements. And then there's a group of people that are enabling the Linux stuff. And any new improvement that goes into SQL just naturally shows up on Windows and Linux. And again, the size of the number of new things coming in the next version is smaller, not because we're doing the Linux work, but because there's a much shorter time frame between 16 and vNext. So this is what the schedule looks like. So we will try to GA in calendar year 2017. What happened? So traditionally, when CTP2 comes out, we offer a select set of customers through our TAP program production support before we actually make SQL generally available. And we have some large customers that basically upgrade their production system once we put out CTP2 in exchange for our engineering team to basically stand around and help them with the upgrades and deal with whatever that may come, right? So it's kind of a white glove, very friendly kind of a relationship with a set of customers. There's their features that they want, so they're willing to upgrade early. But for customers who are interested in that program, basically once CTP2 comes out, Microsoft CSS will support in production use of the next version. We also have this program called the EAP Early Adopters Program, and we're working with some customers who might even go into production before CTP2 comes out. So if you're interested in an EAP program, let me know. Again, I think you all have my email by now. You've seen it a few times, but it's tonypet@microsoft.com. TonyPet, pet like a dog, right? So Tony Pet, no dots, just Tony Pet. And so if you're interested in the EAP, let us know. You can also just search for SQL Server EAP. There's a form you can go and apply, and you don't have to send me an email either. And developing new apps on Linux, we're very much interested. So we're anticipating that some apps will get certified for SQL on Linux and Windows, and there will be some new ones. If you're going to work on a new app, we'd be very interested in working with you, try to help and expedite. Yeah, so there's some useful information here. And there's a links for, so there's a www.sqlserveronlinux.com. You can go and get information. And there's also the SQL Server vNext eap.azurewebsites.net. I don't know who came up with that one. Probably someone on my team. All right. So that's basically SQL Server on Linux and the next version of SQL Server. I'll take a couple of questions and we'll call it good. Anyone? Yes. Yeah. We removed a lot of the constraints in 16, so it's likely that you're not on 16 if you're getting yelled at. Yeah. In 2012, the only... Yeah, 14. And, you know, rightfully so. In 2012, for example, we introduced column store, but it was not updatable. So the use cases were very narrow. But in 16, that stuff is now, like, really... really good, and you can do it for, you know, it covers almost all scenarios. In SQL 2014 was the first version of in-memory, and the scenarios were limited. And we've expanded those scenarios, and we're continuing to expand the scenarios. But, you know, from a performance perspective and a throughput perspective, using in-memory is like you can't beat the performance, especially if you use compiled stored procedures and such. So I would encourage you to continue to demand. But the other thing is that it's not an all or nothing like some other databases. Like you could just have one table which is in memory because it's a critical table, right? So you can mix and match. All right. Yes?
When will be the release of the SQL Server vNext RTM version?
Ask again, please.
When will be the release of the SQL Server vNext on RTM version?
We haven't set that date yet. It'll be in 2017. So no specific dates. All right, that's all the time we have. Thank you very much. I hope you will go and try the SQL on Linux.